Alright, class, this is a review of our lesson 1-2 on solving multi-step equations for algebra. There's a couple vocab terms we need to know about. We need to know about our property of equality, or our properties of equality. We've got 4 of them. We're going to talk about equivalent equations, and we're going to talk about inverse operations. To start off with, let's talk about our property of equality, or our properties of equality. Every property of equality is following basically one rule of what do you do on one side of the equation what you do on one side of the equal sign you do on the other. What we mean by this is if we decide to add some number to one side of the equal sign, we have to do it on the other side of the equal sign as well. If you decide to subtract on one side, you need to subtract on the other. If you decide to multiply on one side, you have to do it on both sides. Because two things are supposed to be equal, if you're going to change one thing, you have to do the same exact change to the other. We'll talk about equivalent equations in a second, using the now you try or our example as a point. And then the last thing is just our inverse operations. Your inverse operation is what undoes some operation. So your operations are adding, subtracting, multiplying, and dividing. The inverse operation of addition is just subtraction. If you want to get rid of addition, you're going to have to subtract. If you want to get rid of a multiplication problem, you're going to have to do division. And the other way as well. If you want to get rid of division, you're going to have to multiply. If you're going to want to get rid of subtraction, you're going to have to add. Eventually we'll see if we want to get rid of x squared, we're going to have to square root instead. The square root and the square are separate things, but that's for the future. Those are sort of inverse operations, just the undo. We'll take a look at example 1. We'll take a look at example 2, and then I'll give you a chance to take a look at the now you try answers. On example 1, we're being asked to write and solve a multi-step equation. So first off, we're going to have to read through this word problem and figure out what we're going to write. The student council raised 2/5 of the money they need to cover the cost of the school dance for the bake sale. They raised an additional $150 selling raffle tickets. If the student council has raised a total of $630, what is the cost of the school dance? We're going to write an equation for the problem, then we're going to solve the equation. The first thing we're going to do is we're going to assign a variable for that unknown cost. We're going to call that variable C. We're saying it's C for cost. We're going to take a look at the additional money that they raised was $150. So I'm going to put like plus $150 here. And the final amount that they've raised altogether so far is $630. So, there's some cost to the school dance. We don't know how much it is for the school dance. But the student council raised 2/5 of that money with the bake sale. So they've raised 2/5 of that cost. 2/5 of C. They've also raised an additional $150. We said that's plus $150. This is the how much they've raised so far, plus an additional $150. Should be our total amount that they've raised so far. Should be $630. This is going to be the equation we're going to work with. We're now going to find out what C is by using inverse operations along with our properties of equality to write equivalent equations along the way until we've got a solution. So, we've got 2/5 times C plus 150 equals 630. The first thing we're going to do is we're going to try and get rid of the 150. We're going to try and get this 2/5 C all by itself. So since I C plus 150, I'm going to use my inverse operation, the opposite of adding is subtracting. We're going to subtract 150 from both sides. We're doing from both sides because what we do to one side of the equal sign, we do on the other. When we do that, the positive 150 minus 150 goes away. We're left with 2/5 of the cost equals 480. Now there are a couple strategies to deal with getting rid of the 2/5. This is 2/5 times C. You could also imagine it a handful of ways. You could imagine it as 2 times C divided by 5 is 480. That's another way to view the same problem. In which case, you just break it up into its two separate operations. We see a multiplication problem, and we see a division problem. And we'll use inverse operations to get rid of the division and to get rid of the multiplication. We've also seen how to divide by fractions. You would have seen that in middle school. You divide by 2/5 on both sides. Dividing by 2/5 is the same as multiplying by 5/2. You'll see a dance cost of $1,200. Just to see that same idea here really quickly, you could, by the way, just enter this into your calculator. You could enter 480 divided by, in parentheses, 2/5. That is something that your calculators on exams would be able to do. Here we can deal with 2 times C divided by 5 by equals 480 by doing our inverse operations. We're going to choose to multiply by 5 to make the 5s go away. We'd be left with 2 times C equals 2,400. Last thing we want to do is divide by 2. Because I see multiplication, the opposite of multiplication is division. Opposite of multiplication is division. And what I do to one side, I'm going to do to the other side. We get C equals 1,200. Just as we said here. You don't have to do all the division at once. You don't have to divide by a fraction if you deal with it as two separate operations. we'll take a look. Pause the video now to try out the Now You Try. Alright. I'm not going to work through all the Now You Try, but I will just read the question and I'll show you the answer we came up on in our class period. Hiroshi's buying a snowboard that is on sale for 3/4 of the original price. After he uses a $50 gift card, the total cost before taxes is $190. We want to write an equation for the original price of the snowboard, then solve that equation. We settled on, in class, calling the total cost, or the original price, or we called the original price, the cost C. And we said, well, the original cost, he's paying 3/4 of that. So 3/4 times C. And since he's using a $50 gift card, it's like the money is sort of coming off of the cost as well. He doesn't have to pay that $190 because $50 is technically already paid. Or he only has to pay $190 because $50 is already paid. 3/4 of some cost, take away $50 from the gift card, gave us a final cost of $190. We used our inverse operations, adding 50 to both sides, to get to 240 equals 3/4 C. We circled these because we were trying to emphasize that these are technically equivalent equations. They were going to have the same answer, and all we did is we used our inverse operations of adding 50 and our property of equality. What we do to one side, we do to the other side, adding 50 to both sides, to get us an equivalent equivalent equation that will give us the same answer. Our properties of equality keep our equations the same, keep our work the same, and don't affect our answers. This equation will have the same answer as this one, and our answer is going to be an original price of $320. I'll add a number sign onto this, $320. Let's take a look at example 2. Hello. You want to say hi to algebra? Good. Recording a video. If you want to say hi to algebra, it's algebra. They don't see anybody.
Oh, okay. Hola, algebra. ¿Cómo están ustedes? All right. Adiós.
Example 2, we're going to solve a multi-step equation with letter coefficients. What we just did in example 1, we're going to do the exact same sort of steps in example 2. If we decide to add to one side, we're going to add to the other side. If we decide to subtract, we're going to subtract from both sides. If we decide to multiply on both sides, we're going to multiply on both sides. We just have an extra letter here that we get to treat like a number. It gets to move around. We could add it, subtract it, multiply it, or divide it based on just what we have. Go for it. Sure. Go for it. We're going to assume that A is not 0 in this problem. Let's just talk about the steps we're going to take. We'll write ax minus 7 equals 5 just to start off with, and we're going to go through the exact same solving steps. Let's add 7 to both sides. Again, using our inverse operations, let's get rid of the minus 7 by adding it to both sides. We get ax equals 12. Last thing to consider is that we just want x by itself. This is a times x. How do I get rid of multiplication? Well, we have to divide. We'll get x equals 12 over a. This would be a good answer for us. Now there's some additional thought I want you to consider. They're saying there's a question of why can't a be 0? Why can a not be 0? We can consider it sort of two ways. If a was 0, we'd end up seeing 12 divided by 0 equals x. But 12 divided by 0 is undefined. Not an answer. That's one reason, or one way to think about it. The other option is if you look up here, if a was 0, then we could imagine that we got 0 times x minus 7 equals 5. Or just simply put, 0 minus 7 equals 5. And, well, negative 7 does not equal 5. That would be one reason to argue that this is incorrect. I'm going to record another video in a bit on the homework we did for this, but you had these book problems on a separate assignment page.